welcome to my channel. Most of you have attended, I think, April 2nd session, JEE mains paper. When I went to April 2nd first shift paper, I found something very interesting. There are around 10 super easy questions which can be solved less than a minute. Do you believe it? Yes, it is true. So, if you are smart enough in identifying such questions, then it will definitely enhance your score. In my today's video, I am going to discuss how to identify such questions and attempt them with maximum accuracy. These are really scoring opportunities. You should never miss such videos. Stay tuned with me till the end of the video, and if you feel that the video is helpful to you, please share it with your friends. Hit the like button, subscribe to my channel. So let's get into the topic. Hey guys, let's see the questions which can take less than a minute to solve. This is from April 2nd first shift paper. The first question is, it's on integration. So some of the questions require a standard result. If you are already aware of the standard result, then it becomes easier for you to solve this question less than a minute. So let's see this question. It's a question from definite integration. And if you look at this integration problem, log of x square plus 4 to base 2 is the inverse of square root of 2x minus 4. So if this is f, this is going to be f inverse. And we have a standard result here. Integral a to b fx dx plus integral fa fb f inverse of x dx is equal to bfb minus afa. If you are aware of this standard result, it exactly matches with the given integration. And upon identifying that a is equal to 0, b is equal to 2 root 3, and f of a is 2 here, and f of b is 4. And if you plug in these values here, so b means 2 root 3 times 4 minus 0 times 2. So it directly gives you 8 root 3. And by this we can identify the answer to be 8 root 3. It didn't take much time if we know the standard result. And the standard result is proved using the substitution. If you want to know that substitution, in this second integral, we will be taking let f inverse of x as t. So then x will be f of t, dx will be f dash of t dt. So overall, that left-hand expression would be limit integration a to b fx dx. When we choose the substitution, then even the limits also are going to change. This will become a to b t f dash of t dt. So when we use parts here, it reduces to integral a to b fx dx plus tft minus integral of ft dt within the limits a to b. And then you can cancel out these two. Obtained expression final value would be bfb minus a fa. So this is actually the proof of that result. But for proving, we need time. But then if we remember the result directly, we can just use the a, b values, f of a, f of b. And this problem can be solved less than a minute. And according to me, it's a scoring question. Let's see the next question. And this is a question from trigonometry. And the standard result is very simple. And we have been using that result frequently in many questions while practicing. Sine theta, sine of 60 minus theta and sine of 60 plus theta is equal to 1 over 4 sine 3 theta. This result is proved using compound angles and also the transformation results, multiples and submultiples. And here the theta is nothing but pi by 18. In degrees, it's going to be 10 degrees. So K value is basically sine 10, sine 50, sine 70, which 50 can be written as 60 minus 10, 70 can be written as 60 plus 10. So the K value comes out as 1 over 4 sine 30, and that is 1 by 8. So on finding the K value and also the sine of 10 times 1 by 8 into pi by 3, overall this reduces to sine 5 pi over 12, which is sine 75. And we are already familiar with sine 75 degrees. That's going to be root 3 plus 1 by 2 root 2. I guess this is also a simple question which can be done in less than a minute. But provided you should know the standard result. Let's see the third question. This is finding the range of a given function. It also has inverse function, inverse trigonometric function. So sine inverse x range is minus pi by 2 to plus pi by 2. We knew this, but here it is sine inverse of 1 by x square minus 2x plus 2. This is sine inverse. I can write this as x minus 1 whole square plus 1. So from this I can say x minus 1 whole square plus 1 is always positive but not equal to 0. X minus 1 whole square plus 1 is always greater than or equal to 1, and its reciprocal will be less than or equal to 1. So from the options also we can identify that range is open 0 to close pi by 2, which is C is the option. Let's see the next one. This is going to be a very simple and straightforward question. The first concept while solving the differential equation is the separable method. I guess this is also a scoring question. So if you separate the variables here, you get dy by dx is equal to minus cos x by 1 plus sin x. Or you can write dy is equal to minus cos x by 1 plus sin x into dx. And upon integrating this on both sides, you get y is equal to negative ln of 1 plus sin x plus c, where c is an integration constant. But if you apply the condition f0 is equal to 0, you will be able to prove that c is equal to 0. So y is equal to negative ln of 1 plus sin x. And when you plug in x as pi by 2, you get negative ln 2. And there is no a tricky application in this question. It's a direct application of a simple concept. So the answer here is negative ln2. This also took less than a minute to finish the question and identify the perfect answer. Let's see the next question. And this is a question from permutations and combinations. There is a long way to do it, but then if you can just pause and start thinking about the question to do it in a short way and read the question. Number of 7-digit numbers which can be formed using all the digits 1, 2, 3, 4, 5 with at least one digit repeated. So we need to form a 7-digit number, and there are two cases. So let's say we will fill out with the 4 letters. One of the letter will be repeated thrice. This is one case. I meant to say digits. One of the digit will be repeated thrice. And there is another case after filling 3 digits, there will be 2 letters which are repeated twice. And apart from that, other cases are not possible because each digit should be taken at least once. So these 3 repeated letters can be chosen among the 5 given in the form of 5C1. Once we choose the letter which is repeated thrice, then we have 7 digits which can be arranged in 7 factorial, and in which 3 digits are same. So we divide it with 3 factorial. And then this is again selecting 2 digits which are repeated twice. And then we have 7 digits to be arranged in the form of 7 factorial, and out of which there are 2 digits which are repeated twice. And if we can add up these two cases, then it simplifies to 16,800. So effort lies in only identifying the cases. The rest of the process is very simple to write down the permutations. Answer is C here. This also didn't take much time to complete the question with accuracy. I feel this is also a scoring question. Let us see the next one. This is an ellipse question. This is also the straight application of the question, of the concept. And eccentricity is given as square root of 5 over 3. And the point 3 comma 4 lies on the ellipse. So I can write down the condition 9 by a square plus 16 by b square is equal to 1. To find the length of latest rectum, we already knew the formula for it is 2b square by a. So in order to evaluate this, we need a and b. One condition on a and b is eccentricity. Other condition is a point lying on it. So these are the two equations with two variables. Solve them simultaneously. Then you get a square as 45, b square is 20. So the 2 times 20 divided by square root of 45. So this identifies the answer as 8 root 5 by 3. This is also a direct application uh, wherein we don't need to spend much time in thinking how to figure out the conditions, because most of the things are very clear. Let's see the next question. A circle meets a coordinate axis in 3 points and cuts equal intercepts. If it cuts a chord of length square root of 14 unit on x plus y is equal to 1, then square of its radius is. With the given conditions, if I had to draw the figure would be something like this. A circle will be passing through 3 points with equal intercepts. And let's say this is a straight line, x plus y is equal to 1. And it has a center here. And if we drop a perpendicular from here, and this becomes the radius, we will be assuming the radius as r. So if this is radius, we are already given with the chord length. So this part of the length is 14 by root 2. And for finding the other part, the distance from here to here is r. So this part of the distance, we can find it out from this triangle, which is 45, and this length is 1. So these two lengths will be 1 by root 2. So this part of the length would be r minus 1 by root 2. And then we use the Pythagoras rule here. R square is equal to square root of 14 by 2 whole square plus r minus 1 by root 2. So this is a quadratic equation. Upon solving this quadratic equation, r you will get it as 2 root 2. R square would be 8. So we can identify this answer also very quickly. Only thing is we need to identify. We have already practiced a lot of questions on finding the length of the chord, perpendicular from center to the chord. So having the knowledge of those things, it's very simple to put up this equation in R and solve for R. Let's see the next question. Oh, number of critical points. This is also an interesting question. At the same time, we can recall the definition of the critical points. Critical points are obtained when f dash of x is equal to 0 or f dash of x is not defined. So these are the two means by which we will find the number of critical points. The function given here is mod of sine x by x when x is not equal to 0. And if I find out the derivative of this, removing the modulus case, x square x cos x minus sin x. And upon equating this to 0, we arrive to the condition that tan x is equal to x. So the number of values which satisfies this equation can be given as the critical points. So for that, we can draw the graph of tan x. We're already familiar with the graph. So this is 0, this is pi by 2, 3 pi by 2. And we need this graph only from minus 2 pi to 2 pi, open interval. So if I try to draw the graph, and extend it to till 2 pi, so this is the graph we are going to get. And when we try to draw the line y is equal to x, and that would be a straight line through this. And you can see the number of points where it meets the tan x within the given region is going to be 3 points. 0 is one of them. The other two are very close to 4 in radians. In case if the graph drawn by hand is not clear, you can actually take the graph sheet with an exact scale and check the slope to find out the meeting points. That would give more clarity on this. And this question just takes around a minute because drawing the graph and identifying and checking the slopes and meeting points might take a little while. Otherwise, this is also a doable question. Let's see the next one. This is a question where we can actually do it with a different method rather than solving it directly. So basically, we are required to find a perpendicular foot of the perpendicular from a point onto the line. The line is passing through 1, 1, 1, having direction ratios as 2, 3, 4. So we can easily write down the equation of the line. Now I will use the substitution method in this case to solve it in a short period of time. So I try to plug in the point A first, but it is deviating at 7 by 29 condition. Then I quickly change the 7 by 29 to minus 7 by 29. C actually satisfies this equation 11 by 29 comma 2 by 29 comma minus 7 by 29. When I plug in this line equation, I got each of them equal to minus 9 by 29. So this is a point which lies on this. And further verification, if I had to do, if you are taking this point to be 11 by 29, 2 by 29 minus 7 by 29. Direction ratios of PQ and the line are perpendicular to each other, so their product sum should be equal to 0. So 11 by 29 times 2 plus 2 by 29 times 3 minus 7 by 29 times 4, it is 0. So with these two conditions, we can conclude that the option is C. And this didn't take much time because I'm verifying the condition rather than solving it directly to get the foot of the perpendicular. Let us see one more question. I guess this is the 10th one which I picked up. If these 10 questions are solved with accuracy, maximum accuracy, scoring 40 would be very easy and in a short period of time. So midpoints of the sides of the triangle are given in this case, and we need to find out the incenter of the triangle, original triangle. So let us draw the triangle here. So knowing the midpoints, it's easy to find out the vertices of the triangle. And if you observe like 5 by 2 and 5 by 2 for two coordinates, it is the same. So they lie here. And this point is 4 comma 5. Uh, we already know that centroid of the triangle ABC will be same as the centroid of the triangle DEF. Centroid of the triangle formed with midpoints is same as the centroid of the original triangle. So it is easy to find out the centroid or summation of the x coordinates of the triangle ABC using the midpoints. That is, let's assume this as x1, y1, this as x2, y2. So this is x3, y3. Since the centroids are same, we can write down x1 plus x2 plus x3 is the sum of the coordinates of the x coordinates of the midpoint. So that gives us 9. Sum of the y coordinates of the midpoint will be same as this, that is 15. And we know that x1 plus x2 is already 5. So by this we can find out x3, and once we know x3 then we can find out x2, then we can find out x1. So similarly we can get all the three vertices, and let's say if those three vertices what we found are 1 comma 5, 4 comma 1 and 4 comma 9. So we identify that it's going to be an isosceles triangle. And in isosceles triangle, if these two sides are same, altitude and bisector would be coinciding in this case. So that means this is a line which is y is equal to 5. In center lies on the line y is equal to 5. So for in center, we already got the y coordinate to be 5. And we can find the x coordinate using ax1, bx2 plus cx3 divided by a plus b plus c, ay1 plus by2 plus cy3. This is the formula used for finding the incenter of a triangle. But y coordinate is easy to find it out there. You need to put an effort to find out the x coordinate because we already identified that it is isosceles and we also know the vertices over there. So that would give us 24 by 9. Then when you plug in this is h comma k in the given condition. So 3h plus k would be 13. And this also takes just a minute to complete the question because solving part is not lengthy here. If you know the concept of the centroids formed by the triangle and centroid formed by the triangle with midpoints is same. So these were the 10 questions in first paper I have identified which can be solved in less than a minute. And these are scoring questions. If you are able to identify such questions to attempt them in the beginning, it saves a lot of time and it will enhance your scores also. Okay, I hope you liked it. Please subscribe to my channel and stay tuned for more such strategies. Bye for now.